Right, welcome to the first lesson 4. Now we're looking at inverse functions, parabola. We're looking at your type y ax squared plus bx plus c, just a basic summary of things you need to know and must be able to do. So, general equation, y equal ax squared plus bx plus c. The a value there will decide the shape of the graph. So if a is bigger than 0, we'll always have a smiley face as a parabola. And when a is less than 0, we have a sad face. So in short, what this means, if we relate it to life, if you are positive, a greater than 0 positive, you'll always be smiley and happy. And if you are negative, a less than 0, negative, will be a sad face. Right? To plot these graphs, we must be able to find x-intercept by making y 0 and y-intercept by making x 0. So x-intercept, if I make that 0, here we're testing your factorization. For y-intercept, you substitute in the place of x and you find the value of c. So whatever c is, that is automatically my y-intercept. You can just write y equal to c without substitution. In the graph itself, here where it makes contact with the y-axis, that's referred to as my y-intercept. These two values 1 and 2, where it makes contact with the x-axis, those two are referred to as my x-intercept. We also have what we call axes of symmetry, which you should have learned from primary school. That line cuts the graph in such a way that this side and that side looks identical to each other. Right, so there where it makes contact with the x value, that's referred to as my axis of symmetry. And here where the x and the y make contact on the graph on the axis of symmetry, that's referred to as my turning point. So we technically, when we want to draw this, we're going to have to find x-intercept, y-intercept, and turning point to correctly plot a parabola. Right? So for axis of symmetry, turning point, domain, and range, right? So if we have that general equation to get axis of symmetry, x equal negative b divided by 2a. That's the formula I'll be using in the next lessons, minus b over 2a. To get the turning point, p and q, right? And take note, they don't want you to use p and q no more. But yeah, it is p and q. So axis of symmetry, instead of writing x, p equal minus b over 2a. The answer I get here, I substitute back in that equation there. So there in the place of x squared, I have p there, and I solve for q. So this value I get for p and q are referred to as my turning points. Right? Domain is explained in straight line for basically all the graphs we do in school level, x element of real numbers. Right? Except for the hyperbola. There's the extra attachment. Now, if a is greater than 0, if a is positive, alright, the range y becomes greater or equal to q. Right? Or we can write the range, right? It goes from whatever q value, close because it's equal to q, all the way to positive infinity. We don't know where it ends, so it must be an open bracket or open parenthesis. If a is less than 0, then there you see the sign y less or equal to q. So in short, a greater than 0, the graph is going up, therefore my range greater or equal to whatever the lowest value was at the bottom. If it's negative, my range y or less or equal to q, whatever the highest value was on the top going down. So it goes from negative infinity all the way to where it stops by q. Right, so hope you understand. If you're enjoying the lesson, please like, share, and subscribe. It's the only way you'll stay up to date with all the new lessons coming on constantly. Continue practicing. I wish you nothing but the best.